Alright, so in this series of videos, we will be considering the linked list data structures. So I'm going to assume that you have some familiarity, maybe have seen these types of objects before in maybe a class you've taken from a while ago and you just want to brush up or maybe prepare for an interview, so you need to go back and revisit these types of data structures. So in this series of videos, we'll be considering the variants of linked lists, so singly linked lists, circular, doubly, these sorts of things. We'll be going through each of these objects in detail and seeing what types of operations you can perform on these, and then we'll also be implementing these data structures in Python, and as I go through a particular operation for this list, we'll take a break and move over to the terminal to see how we can actually implement that operation using this idea. So just to refresh, I'm going to first talk about singly linked lists, which are the most basic type of linked list types of data structures. Just to give a brief overview of what a linked list looks like, this is it depicted, a very simple version of a linked list. Every linked list is consisted of nodes, so these boxes here are what we call nodes, and every node has two components. One is called data, one is called next. So the data component, every node has this, and it allows a node in this list to store some element of data. The data here is just a character, A, B, C, D, but data is meant to be interpreted to be possibly more general. So it could be strings, it could be characters, it could be numbers, it could be other types of objects. We also have this component that every node has called next, which is a pointer that points from one node to another. So this node here that stores A has a next pointer that points to the node that is next in the chain or the list, which stores B, and so on and so forth. So B, this node here, has a next entry that points to this node with the entry C. And the start of the list is referred to as the head. So the head is kind of where we are looking. So it's a pointer that points to the start of the list. If we want to traverse the list, this head pointer that's looking at each of these nodes in the list will have to move along with us to figure out where we are in the list. So if we want to iterate through the list, we'll see this in greater detail later, the head pointer will have to traverse along the list in order to obtain or access an element of the list. The last component of a singly linked list is this notion of null. So the end of any linked list is terminated by this null idea. So it's in Python, we'll see this as we'll call this none. It's just the next pointer of the last node in a singly linked list points to this null object. And that just tells you that it's the end of the list. So very quickly, just to give a brief overview of how arrays and linked lists are different, this is probably kind of a good thing to keep in the back of your mind. Arrays and linked lists when it comes to insertion or deletion. For an array, the insertion deletion operation is on the order of n operations, and that is because if, in the worst case, if we need to insert an element in the beginning of the array, this will involve shifting all of the elements in the array to the right so we can make room for the element that we want to insert or delete all the way on the left or in the beginning of the array. However, for a linked list, once we know where we are in the list, if we just need to insert or delete an element into that list, that is a constant time operation, and it just involves shifting the next pointers around or the previous pointers around, so that way we can insert or delete the element into or delete the element out of the list. Accessing elements, so for arrays, they do better for linked lists. They're a constant time operation. If you give an array an index, it's able to immediately give you the element at which the entry is stored. That's because arrays are contiguous, which this table goes into a little bit more detail about, which we'll get to that in a bit. Accessing elements in a linked list is an order of n operation, and that is because as we traverse in this list, if we want to access, say, this element down here, we need to have the head pointer traverse the entire list before it can actually get to that node in the list. And as I alluded to before, arrays, when you create an array object, it is contiguous in memory, which allows this access time to be constant, whereas linked lists, you do not have the luxury of contiguous memory. So these are tables that you should probably keep in mind when it comes to trade-offs between arrays and linked lists. If you're given a problem, you might want to consider whether or not an array is the preferable data structure or a linked list, or just be aware of these types of pros and cons. So the first thing that we're going to look at how to do in Python with a linked list is this idea of insertion. So there's a few different ways we can insert to the list. We can add an element to the back of the list. We can add an element to the front. We can add an element in between nodes. So we'll take a look at each of these operations, and we'll take a look at how we can actually perform them in Python. The first one is adding an element to the end of the list, which we'll call append. So we're appending it to the end of the list. So if you have a linked list that looks like this, and you have an entry, let's say another node here that's denoted as E, if we want to append this to the list here, the outcome of that will be the list that we have with E wedged in between this and the null component of the list, and this is what append looks like. So actually, before we move on to the other types of insertion methods, let's actually go ahead, code up a linked list implementation in Python, and start to think about how we can actually do this operation. So I've created a Python file here called linklist.py, and what we're going to do is we're going to create two classes, one which is a class for the node object in a linked list, and one which is a class for the actual linked list itself, which consists of nodes. So just to go back to the figure here, just to refresh ourselves, a node, we're going to create a class for what a node object looks like. So this is something that has a data and next component, and then we're going to also create a class for a linked list. It's a single linked list, we'll call this linked list for now, and this just consists of nodes. So let me minimize this and let's go ahead and create our classes. So we'll create a class called node. In the constructor of this class, we'll give it the argument of self and also data, because this is going to be, remember, every node is going to consist of next and data. So what we'll do is we'll say self.data is equal to data, which is what we're passing in to define an object of this class, and then we'll say self.next is equal to none. So this is something that we'll set as we make use of the node, but initially we'll set it to none. So that's pretty much all we need for the node class. Now let's go ahead and define a linked list class. And here what we're going to do is in the constructor, we'll have, again, self, and then we'll have a component which, if we go back to the figure again, the start of the list, if we want to start a fresh linked list, we'll give it the head pointer. So the head pointer will point to the first node in the list, and we'll initially just set that equal to none, or to null. So we'll say self.head is equal to none. So what we can do now is we can go back again to the presentation, and the first thing that we want to do now that we have a linked list type of infrastructure set up with these two classes is we want to append entries into this list. So let's actually, before we do that, let me just go to the main part of the program, and let's define a linked list object. So we'll say linked list is equal to linked list, and then we'll eventually, what we'll do is we'll say linked list dot append, and then we'll give it something. Let's say a linked list dot append, let's say b, and then we'll also want to have some way to actually print out the elements of the list. So let's go through and actually create the append function. So we'll create a method, which is a class method called .append, or append rather, and it's going to append in a node onto this list, and this node is going to consist of some data component. So we'll also need to pass in that data component. So let's go back to our figure. So when we have this list, assuming we have some list here, we need to do a few things to append. First, we need to check if this is totally an empty list. If the list is not empty, if we're appending a node in the list for the first time, we need to take care of that case separately than if we already have a list and we're appending it to the end of the list. Let's take this easier case where we actually just don't have anything, we have no list, and we just want to append the first node to that list. Let's minimize this. So the first thing that we want to do there is I guess in any case, we want to define a new node, and we'll use our node class to do that. So we'll define this new node equal to a node object, and we'll pass it in data. So this new node object that we have now is a node, and it consists, the data field of this node has the entry of data that we passed into this append function. And we want to take this new node that we just created and append it onto the list. So the first thing we want to do is we want to check if the list is empty. So the way we can do that is we can check if the head of the list doesn't currently have any component. So we can say if self.head is none. If this is true, then this basically means that there's nothing there. The head pointer doesn't point to anything at all, and therefore there is no component in the list. There's no node in the list. If this is the case, then what we can do is we can set the head pointer to the new node that we just created. So we can say self.head is equal to new node. And if that's the case, we can just return. That's it. So that case is relatively easy. So what do we do now if the list is not empty and there's other entries in the list? How do we deal with that? What we can do is we can say, let's go back to the figure because I think it makes it a little bit easier, is what we can do is we need to actually get to the place where the new node needs to be inserted. So let's say we have a situation like this where we already have a list and we have this new node that we've created and we want to append this to the list. So what we can do is we can start off here, the head pointer starts off here, and we can move the head pointer through each of these components in the list, each of these nodes in the list. And when we get to the end, when we get to null, we know we've reached the end, we know that's where we want to actually input the new node. So first we need to figure out how do we move from one node to the other using the head pointer. And once we arrive at the location that we want to insert the new node at, how do we actually go about putting that new node into that location? So what we can do is we can define, let's say, what we'll call last node, and this will initially be equal to the head. So we're at the start of the list, we define this variable to be called last node because that's what it will eventually point to. But at the moment, it just starts off at the beginning of the list. And what we want to do is we want to move through that list. So while the head pointer doesn't point to null, we want to move through. Start off head here. Is this pointing to null? No. Move on to the next one. Is this null? No. So on and so forth until we get to this. And then when we get to that, that's when we'll go ahead and input our new node into the list. So what we can do is we can say while last node dot next. So basically while this is not null, while the next pointer of the node that we're currently on is not null, we're going to continue in this loop. So what we're going to do in this loop is we're just going to move the head pointer to the right. So we're going to say last node is equal to last node dot next. And then after this loop has concluded, last node will point to the last node. So again, we point initially to head while the next pointer does not point to null. We continue on. This basically just moves the head pointer to the right. So while it's not null, the next pointer is not null. We'll start off here. Is this next pointer null? No. Move here. Is this next pointing to null? No, it's pointing to C. Is this next one pointing to null? No, it's pointing to D. Is this next one pointing to null? Yes, it is. So we are at that point now. So what do? Well, we need to insert the node. So we can say, if that's null, we can say last node dot next is equal to the new node that we want to insert. And that will append the node to the end of the list. So at this point we have an append function, which is great, but we want some way to verify, or we want some way to print out the components of the list. And the way that we're going to do that is going to be pretty similar to what we did for this append function, and it will also allow us to verify that the append function is actually working as expected. So let's create a function which we'll call print list, and it's a class method, so it will just take self as an argument. And what we're going to do is we're going to print out the entries of a list. So how do we do that? Well, again, if we start off here, let me just go back to the general picture of a linked list. If we start off here, the head pointer starts at this component, this node here. So what we can do is we can say, okay, we're starting off here, we're at this node, print out the data component of this node, and then move head to the right. So check if the next is not null. If it's not, move head over there and print out the data field of this node. And then just keep doing that until you hit this null terminating component of the list. Once you do that, you know you've reached the end of the list. So that's pretty much all we need to do. So what we'll do is we'll say, let's say current node is equal to the head of the list. And then while that current node isn't null, so while current node is not none, or while current node, it's just a shorthand for the same thing, we're going to say current node is equal to current node dot next. And before we do that, we'll actually print out the data. So we'll say print current node dot data. And so as we do that, we'll print out the data field of each of the nodes, and we'll iterate on through the list by just going to the next node in the list from this line here. And that should be all that we need there. So if we go ahead and write this, let's go down here. So we've appended both of these things to the list, and if that actually did work, hopefully we can say list.printlist as well, and this should print out, I guess in reverse, B and A. So let's write that, and let's give this a run. So python linked list.py. Let's see. So it looks like I forgot to add parentheses here, and if I write that and now run it, then I'll see here that we have A and B. So it does indeed append to the list. We have this A, which is now the first element that we appended from the first line that said append A, then we append B, and then print list was able to go through starting off at the first node in the list and print off all of the elements in that list. So it's able to do both of those things appear to be functioning as they should be. So the next thing that we're going to do is go back to the slides, and we're going to look at another method of insertion, which is prepend. So instead of adding a node to the end of the list, in this case we want to add it to the beginning of the list. So again, we have this linked list, let's say here, and we have this new node. What we want to do is we want to prepend it, which basically will just look like this. So we've taken this new node that we have here, and then we just move it to the beginning of the list. So we prepend it to the beginning. So what is going on here? How do we go ahead and do this? Well, what we can do is the first step, just like we did for append, is we create a new node based on the data that is passed in. So in this case, that data field is E. And then what we can do is we can consider this head of the list. So what we want to do is we want to say that this new node, this next component, should point to this guy. So we need to change the next component of this to point to the head of the list. And then we want to move the head, because the head is still at A. We want to say that now that we've prepended, the head should move to this element of the list. So that's really kind of a two-step process, maybe a three-step process, because we're creating this node as well. So let's go ahead and step through that. So we'll create a function, which we'll call prepend. This will also take self since it's a class method and data since we need to tell it what to prepend to the list. And then what we're going to do is we're going to, as we did for append, we'll say new node is equal to node of data. So we're creating a node here. And then what's the first step? So going back to this picture, what we need to do is we need to say, here's our new node that we've just created. We want the next field of this node to point to the head of the list. So how do we do that? We can say new node.next is equal to head. So basically what we're doing is we're saying draw a line, draw an arrow if you like, from this new node that we've created, draw a line or an arrow to this thing. So make it point to the head, the current head of the list. We'll have to change the head. That's the next step. So now that we've pointed this to the current head of the list, head is over here right now above the A. And we need to move the head. We need to say now that we've prepended, head of the list is now this component here. So the way we can do that is we can say self.head is equal to new node. And that's pretty much it. So we've gone ahead and prepended to the list. So let's go ahead and see if this works. Let's say llist. Let's actually just make this very similar to the picture. So we'll say append C, append D. So if we go ahead and print this list out, we haven't prepended anything. We have a list that looks like very similar to the one that we have in the figure. Now let's try to do what we did in the figure, which is what we prepended the component E to the list. So if we go ahead and do that, we now have not A, B, C, and D, but E is now prepended to the beginning of this linked list. The last insertion method that I want to consider in this video is inserting after a given node. So we have a linked list just like we had before. We have this node, and we want to insert after a given node in the list. So basically what we want is we want something that looks like this, where we'll have a list now where we've taken this new node we've created, and let's say we wanted to insert after this node B. So we've kind of wedged this new node in between B and C. So that's one example of what we want the outcome of the list to be in this case. So let's break down exactly the steps required for us to do this operation. The first thing, as always, is we need to create the new node given the data that we're given. And then we need to check if the node that we need to insert after is even in the list. So if it's not in the list, we'll just return because it's not there. We can't insert it after a node that's not present in the list. If it is there, say the node is B, then what we need to do is we need to do a few things. So the first thing that we need to do is we'll have something that looks like, let's say, like this. So we have this new node we created, and then we do this, where we have had the next pointer of this new node point to the next pointer of the node that we were given. So we were given B, the next pointer points to C, and we want this guy to point to that C. So we say new node.next is equal to this node.next. So now they're both pointing to this thing here. But B is still pointing to C. So we need to change this arrow to point over here. So what we can do is we can now change the next pointer from here to point to this thing here. And then what we want to do is we want to make sure that this thing goes away. So if we have that, we have all the ingredients needed to insert after a given node. So let's go ahead and let me just undo that so we have that for reference. And let's see, let me go back to minimize to go to the code. So we'll create a new function called insert after node. It'll take self since it's a class method, and we'll also take the, let's say, the previous node to insert after, and then data, which is what the new node should consist of. So the first thing, as I mentioned, is we want to check if the previous node that we're given is even in the list. So if not previous node, if this node is not there, we must say that the previous node is not in the list, and therefore we can't insert after it. We'll just return. Otherwise, if it's there, we'll create a new node as we've always done for all of the other insertion methods. And then what we'll do is we'll say, let's break this down again. Let's go back to the picture. We'll say we're going to do this thing. So we're going to say the new node, the next pointer of the new node should point to this guy here, which is previous pointer.next. So we want this picture to be a thing. The way we do that was we say new node, the one we just created, .next is equal to previous node.next. If we do that, that's essentially going to give us this picture here. So new node.next points to previous node.next. Again, in this case, previous node is B. The next thing is this C node here. Right, so let's go back to the code. So we have that, and now the final thing we want to do is we want to say the previous node, so let's go back to the picture again. The previous node, this thing, needs to now point to this guy. So what we want to do is we want this thing to happen. So we want the next pointer of this guy, we want to get rid of that as well. We want the next pointer of this guy to point to the new node. So we can say previous node dot next is equal to new node. And if we do that, that should be all we need to insert a node after another one. So let's go ahead and try that out. So let's try to get rid of this. And what we want to do is we want to have a list that looks exactly like the one that we've created here. So let's say that we give it the previous node of B, and we want to insert E in between, just like we've done in the picture. So what we'll do, we have the list there, A, B, C, D. We'll say list.insert after node. We'll give it, so the way we're going to actually feed in the previous node is like this. Before I actually print out the list, let me just do this. So if we want to refer to that node, B, the way we're going to send that information into the insert after node function is like this. First of all, let's just observe what happens if we say list.head.data. So if we print this thing out here, let's go ahead and give this a print. So we've created the list up above, A, B, C, and D. And what I'm doing now is I'm printing the data component of the head of the linked list. So what should we get? We should hopefully get A. A is the head of the linked list. So as we can see here, this is the head of the linked list. This is the data component of the head of the linked list, and that's what was printed out. So what I want to do is I actually want to give the previous node of B. So the head is A. I want to give it dot next. So essentially what I want to do is switch this around. So the next node after the head, if I print out the data of that thing, I should get B. And indeed I do. So I get B, which is printed out there at the bottom. So this, I'm not going to pass the data field, but I will pass this thing over as an argument into the previous node, into the insert after node function. So what I'm going to do is I'm going to say insert after node. The previous node, as I mentioned, is that right there. That refers to the node consisting of data element B. And then I'm going to give it the data of E, which coincides with the picture. And I also need to make sure that I say LList dot to make sure that, because it's a class method. So, okay, so if I do that, go ahead and run this. And actually, before I run it, let's print out the list after. So we should see something similar to what we saw in the picture. So now if I save it, run it, what we see here is we see A, B, E, C, D. So E is wedged in between B and C, just like we had in the picture here. And that is pretty much it. So in the next series of videos on linked lists, we'll be continuing to build on this code. We'll be running some other methods in this class that we'll be writing for manipulating this linked list, singly linked list data structure. So all the code that I'll be writing in every one of these videos will always be up on my GitHub link, and I'll provide a link to that in the description below. If this video was helpful to you, please let me know by liking, subscribing, or commenting. If you have any questions or concerns, please don't hesitate to ask as well in the comments or contact me directly. Thanks again for watching. I hope this was helpful, and have a great day.